In this unit, among other things, we've been talking about the basic things we know about the atom. And actually, this is a slide from earlier where we talked about what we know about the atom has changed over time. Remember, we started with Dalton, just knowing that matter is made up of these mysterious things called atoms. Thomson recognized there were positive and negative charges within an atom. Rutherford actually recognized the idea of a concept, the idea, excuse me, that atoms have a nucleus where the protons and the neutrons are. And then Bohr actually said, well, hey, the electrons are more organized than you think. And actually, we're going to pick up kind of where Bohr left off a little bit. Bohr said that the electrons actually, these are electrons associated with the nucleus of an atom, and that the electrons are organized. So, for instance, you kind of see this guy. Let me kind of, I'll call him A and I'll call him B. Can you see where A is closer to the nucleus and B is further from the nucleus? And what Bohr would say, as I understand it, was that the electron here that is closer to the nucleus actually is lower energy, lower E, and this electron out here is higher energy. So we're going to be talking about how electrons associated with an atom are not all created equal, and that's kind of what Bohr said. Well, Schrodinger actually took it a step farther, and so Schrodinger is the current model. Again, it has to do with electrons. The caption down here says that Schrodinger came up with the concept of the electrons existing in a cloud, and that's actually the real deal. So when you see Schrodinger's model, kind of these things that kind of make you look a little bit itchy, those are actually electrons, kind of a general region where an electron is. It's not that there are that many electrons associated with an atom, it's just kind of generally where the electrons are. So Bohr and then Schrodinger is kind of, to me, kind of broke out the whole electron thing. So this kind of looks like maybe the Bohr model. And so again, we have the nucleus. We've been talking about the nucleus. What subatomic particles are in the nucleus? Protons, its atomic number, and neutrons, various number of neutrons, gives us isotopes in the nucleus. And then outside the nucleus, of course, we have electrons. And what Bohr said is that electrons can exist here. This is going to be, this variable n means principal energy level. I'll just put principal energy, E for energy level. So Bohr said that electrons can actually be at this energy level, this energy level, this energy level. See, as I'm going up, I'm getting farther from the nucleus, and actually, as it turns out, I am increasing energy. So there you go. Then the Schrodinger model actually takes it up a notch. Schrodinger recognizes that it's not a gravity thing, and it's not like electrons are orbiting the nucleus. It's an electrostatic thing, and they're kind of buzzing here and there. One of the things, according to the Heisenberg's uncertainty principle, is you can't know the location, the exact location and the exact energy of an electron at any time around an atom. I think that's pretty cool. The other thing that Schrodinger introduced is this concept, and we're talking a little bit more about this, is that the orbital, the electron, this is all about electrons, the electron orbital is kind of a region of space around the nucleus where you expect electrons to be. And I'll warn you that not all orbitals are spherically shaped. I think that's kind of exciting too. So let's see if this video works for us. Maybe. There's not a lot to it.
A familiar depiction of the atom shows electrons orbiting the nucleus like planets around the sun. This model is neither accurate nor useful. We no longer think of electrons as orbiting the nucleus, and we cannot predict their location with accuracy. A more useful model is the quantum mechanical view of the atom, which represents the positions of electrons in terms of their probability of being in a particular region around the nucleus. If we could show all positions for an electron with a specific quantized energy, the resulting picture would look something like a cloud.
Yeah, I guess that did work. Okay.